Okay, so it is imperative, Kyle, that you, as well as your compadres in class, okay, watch the instructions on the board as we go along. If I'm going too fast, I want you to make a note of it to me, say something. But what you should have in front of you right now is a ruler that reads centimeters. And you'll notice that on that scale, there is one side that divides the centimeters into millimeters. We're going to want that. You have your paper that I handed out, which has 3 lines on it. And I think what I'm going to try to do is, I know I want you to see the screen as well, but Jade, could you please put one light on, because I'm afraid that my lines aren't going to come out with enough. Let's see if that helps out. Let's try, that's weird. I don't know why. Let's try, switch the lights. Switch them. So let's just go with, I think it was better without any lights. Do you agree? Let's put the lights off. Okay. Yes, Jason. You know something? I need the light for this, and that's kind of where I'm hoping to get light on my paper. There's a little more light. Let's leave it like that, because I need the light for my paper. Okay, so ruler, paper, pencil, table of square roots. Now, what we're going to do is we're going to introduce a new scale. Now, the scale we're going to introduce, we're going to give it a name. Okay, now let's give it that formal name. We're going to develop what's called a logarithmic scale. Now, we've been most familiar with what is called a linear scale. Agreed? When we go ahead and we look at a football field, we see a linear scale. What do the hash marks represent? 1 yard. And a scale is, every mark is 1 yard, just like our stick that we have in front of us, which we call a ruler, has a scale on it. On one side we see inches, the other side we see centimeters, and millimeters are the little marks. So what do we use linear scales for? What's the simplest thing we could do? If I gave you, for example, a segment, and that segment was the same length on our scale as 8 centimeters, okay? So let's pretend we have 8 centimeters, okay? And I gave you another segment that was now 7 centimeters. So let's watch my example on the overhead. Okay, so I'm going to take a line, and I'm going to draw a line, and right here I said, wait a second, I have a segment that is 8 centimeters long. And then I have another segment over here. Okay, I'm just going to come here, and this segment is 7 centimeters long. So far, this is 8 centimeters, and this is 7 centimeters. If I cut those up, okay, if I cut them up, so I'm going to go frantically right now, is I'm going to get my scissors out, and I'm going to cut them up, and you notice I've cut the first one. Here's the 8 centimeter cut, okay, and I'm going to do the best I can to make my paper that long. Okay, and watch, I go like that. Okay, do we agree? That's my 8 centimeter segment right there. And I'm going to grab my 7, and I put my 7, and I cut it. When I put these two things together, and I add them up, what do I get? I get a segment that is what? 15 centimeters long, right? Do you see how the scale that we typically use on rulers is very good to add numbers up? And that's what we use it for. In fact, in geometry, we learned about what was called the ruler postulate and the segment addition postulate, and how we could butt segments together and put them back into number land and get the answers, right? And that's the whole premise of what you did in geometry. But now what we're going to do is we're going to make a new scale. This scale that we're now going to build today and start is going to allow us to add segments up so we can multiply numbers, which is not very practical with the existing scale that we have in front of us on the ruler, right? So we're going to make a new scale. Okay, so the first thing is, remember, we want to add numbers up on our new scale so that they represent us multiplying numbers. So let me get this blank scale in front of me again. And let's start with some assumptions. That on my scale, on my segment, that let's mark it up. This end here is going to be 1. That's going to be 1. Okay, so is everybody clear? I marked 1 here. And I'm going to put it as a hard marker here so people can see 1. Now this far right side, I'm going to mark that as 10. What are we used to our linear scale being? 0 on the left, isn't it? And then what? Maybe 10 to the right, and then it would be 20, then 30. But here, when we multiply numbers, we multiply by 0, what do we get? 0, right? So we're not going to have a 0 on our scale because we know the answer if we multiply any number times 0 is 0. 1 times a number is going to give us another number. And that's like an identity, so we should know the answer to that one. But let me ask you a question. What 2 segments could I add up that would be 10? Now, when I ask you what 2 segments that you add up to give me 10, what I'm really asking you is what 2 numbers would I multiply together to be equal to 10? What would be that? What would be the number? What's the number? Somebody. What's that? No, I said the same number now. Okay, so what's the exact... Okay, now 2 and 5 would work, okay? And maybe I wasn't clear the way I described that. If I had to pick the middle of my line, remember I want to make 2 exact equal segments, and I want to add them up so that I get the number 10. What would be the value in my head that I need to add to the other to 2 numbers? What are the 2 numbers I add up? James? Square root of 10. So do you understand my segment length? Half of this number line, if I'm going to add it up, half of the number line has to be the square root of 10. Okay, now your number line in front of you that is blank, that we're going to start assigning numbers to, the halfway point has to be the square root of 10. What is the decimal? When we did the manual square root, what did we find the square root of 10 to be? Now, just to be sure, I'm going to use my calculator to look at it. I don't want you to. I want you to be able to understand that with the manual square roots, we did it. So when you did your manual square root, and there's that YouTube that showed you how to do this, I got 3.1622. So we're not going to be able to write 3.1622, but I think 3.16 is good enough. So now measure 12.5 centimeters in from the left, which is the midpoint, because this segment is 25 centimeters in front of you, and put a mark right at the halfway point very cleanly. Okay, and you see where I put mine now on my overhead? And I'm going to label that 3.16. Okay, so it's 3.16. And I'm going to label it underneath, and I'm going to label it on top. So let's put 3.16 on top as well. And that will become evident in a little while. Does everybody understand why we did what we did? I'm going to add up a segment length of 3.16 to a segment length of 3.16. And what does that represent when I add up segment lengths with a log scale? It's like multiplying numbers, right? So what number does this 3.16 represent? Square root of 10. So I add those 2 segments up. What's my answer going to be? 10. Okay, so now the question is, how long is a segment that on a scale, this log scale of 10 going to be if I add them up together, 2 equal length segments, and they come up to 3.16? What is going to be that number? Okay, discuss that in your groups for a second. Okay, so that way, okay, discuss what number do you think I'm looking for? Not the decimal, but other representation. Okay. Kyle, your table, what did you guys come up with? I don't want 1.77. What? Okay, you're probably giving me the right decimal. Don't get me wrong. What is that? How did we find the first halfway point? We found what? The square root of the number that from 10, right? We found the square root of 10. So what does your 1 point something number represent? Oh, the square root of 3.16. Good. But we know that's the square root of 10, right? What's another way to say the square root of the square root of 10? Because that's what the number is, right? It's the square root of the square root of 10. What's another way to say that if you use scientific type or exponent notation? Yes, Andrew. The fourth root of 10. So the next one, okay, so let's amend our number line a little bit. Underneath 3.16, let's put square root of 10 over 3.16. Let's put the square root of 10. And let's also write 10 to the 1/2 power. And let's write 10 to the 1/2 power. So we're really numbering these things decimal, radical notation, and then exponential notation. Okay, so now, since we know that 12.5 centimeters is the halfway point, what would be the 1/4 point? It would be what? 12.5 divided by 2, correct? Would that be 6.25 centimeters in? Let's do that. Let's measure 6.25 centimeters in. And let's put a mark there. 6.25 centimeters in. And I want to make sure my mark goes above and below the line. Because what we're going to do is we're going to use our scissors and we're going to cut this up in a little bit. Okay, and so let's first of all, what did we do first? We did a decimal representation, right? So we did 10 to the 1/4 power, and that's 1.78 rounded. So let's write our decimal first, 1.78. Write that on top as well, 1.78. In radical notation, how would we write that? Radical with our index of 4, correct? So let's work radical with an index of 4 of 10, so the fourth root of 10. And let's write it in power notation with an exponent as 10 to the 1/4 power. Now, I know I did not ask you to do this next one, but we understand, we'll use the calculator for it. What number is halfway between 1 and the fourth root of 10? What number? The eighth root of 10. Good. So I'm going to use the calculator now, and you can use it too at this point. You can use the calculator, and you can find what is the eighth root of 10. So I'm going to say 10 raised to the 1/8 power, and I get 1.333. Let's just round that to 1.33. How many centimeters is that in from the end? What? 1/4 in was 6.25, correct? Would you go at 3.125 centimeters in from the end? Okay, so let's do that now. Let's all mark that. 3 point, and again, we're having to do our best to get 125, right? I'm not saying you're going to have this exact. I want us to understand the concept of how the scale is built. So I'm going to put 1.33 first. Then I'm going to put the eighth root of 10. And then I'm going to write it 10 to the 1/8. Oops, I kind of zooped that on the video, and I really didn't want to zoop it. I was okay with it. I'm going to erase it and then just write 1/8 power. What's another way to write 10 to the 1/8? Is it 10 to the 1/4 to the 1/2? Isn't that another way to write it? Or could it be 10 to the half to the half to the half? Would be another way to write it. We see the pattern going on here? Let's stop for a second and think about it. Could I keep doing this process indefinitely to get markings on my scale similar to what I've got as millimeter scale marks on a centimeter. You guys understand that I could do that? And you could use the algorithm that I taught you on how to take the manual square root of a number to now find what is the 16th root of 10, the 32nd root of 10, and so on. We agree? Okay, so the question is, let's start to put together some other numbers on our number line. Now we know that 10 to the 1/8 represents, what did we say it was? Was it, I got to measure. I'm going to put my ruler on it. It measures 3 point what? Is it 125? Okay, so I'm gonna write that number down because I'm going to forget it. I'm going to write down 3.125. That's that one. Okay, and then this one is 6.25. This one turned out to be 12.5. Okay, I got it. So what I want you to do now is we're going to add the numbers up. 3.125 plus 6.25, that's 9.375. Measure 9.375 centimeters. 9.375. 1, 2, 3, 7, 5. That's about right there. Okay? What number is that? Now, obviously, I'm going to write above it where I'm doing this linear scale. That represents 9.375. We don't know what that means yet. What does our scale do? It adds, so we then what? Multiply, right? By adding, we multiplied. How many segments of 10 to the 8th did we add up to get to that 9.375 centimeters? How many segments did we add up? 3 of them, right? So isn't that like saying this number times that number again 3 times? How do we write that normally? Don't we say that's like a number cubed? What is our number we're beginning with? Our number beginning is 10 to the 8th power, right? And if we're cubing it, how do we write that another way? As 10 to the 8th, right? Now, we haven't figured out what the decimal is yet. We'll do that in a second. But underneath it, why don't you write, okay, the 8th root of 10 cubed. Is that in radical notation? Is that reasonable? Okay, the 8th root of 10 cubed. And would you agree in exponential notation, we would write 10 to the 3/8 power? I'm going to use my calculator to get me the decimal. So I'll save you guys. You guys could check it. Try it in your calculator. Make sure you're getting the right answer. I got 2.37. Do we agree? So that number is 2.37. A-okay so far? Got it? Okay. What we want to do is mark up the second half of our number line. So let's go ahead and what's 5/8 of 25 centimeters? So 0.625 times 25. The next mark we'll have is at 15.625. So measure 15.625. 15.625. Okay, that's the 5/8 mark. And the 3/4 mark would be 0.7, like 75% of 25 centimeters. That's 18.75. Let's mark that one up. 18.75. And the last one is 87.5% of 25. So I'll put 0.875 in my calculator times 25. And I get 21.875. So I'm measuring 21.8. What's that? I tell you what, I'll mark. Okay, this one is, I forgot to mark it either too. I'm going to mark this one at 21.875. And then 3/4, so 0.75 times 25. is 18.75. This one here is 18.75 and 5/8, so 0.625 times 25 was 15.625. 15.625. Okay, so let's go ahead and figure out the decimals. Now let's work backwards this time. Here's what I want to do, work backwards. Let's write all the exponents first. That fifth line is what? We added up 5, 10 to the 1/8 power, right? Would you agree it's 10 to the 5/8 power? And then we have what? 10 to the, would 6/8 power be the way to say it, or how about 3/4 power? 3/4. And then 10 to the 7/8. And what's 10? How would I write 10? Would I write 10 to the 8/8? Or 10 to the first power, right? Let's write it 10 to the first power. Now, let's go back to 1. What's the way I'm going to write 1 as 10 to a power? 10 to the what? 0 power, right? Okay, got it. I hear you guys saying that. 10 to the 0 power. Okay, so let's finish off our radical notation. This is the 8th root of 10 to the 5th power. This is the 4th root of 10 cubed. This is the 8th root, index 8 of 10 to the 7th, and we'll leave 10 on the number line. Let's work the decimals out. Tell you what, you work the decimals out for 10 to the 5/8 power, etc. We'll double check our answers in a second. I'm going to put the video on pause so that we can do our calculations. Okay, now we've come back. We've checked our numbers, and we, just to reiterate, we have 4.22 that represents 10 to the 5/8 power, 5.62, 10 to the 3/4 power, 7.5 rounded for 10 to the 7/8, and we got 10 as 10. Now, we've made sure we now have the numbers on top and on the bottom. So what I want you to do now is I want you to grab your scissors, and we want to cut out, I always say start this by cutting right on the line. Cut exactly right on the line. Okay, so as I'm cutting it, I'm trying to do the best I can to follow the line. And when I'm done, I'll be done about the same time you are. Okay, so there's my 2 lines cut in half now. And what I'm going to do is I'm going to take my ruler that I'm using, and I'm going to put it underneath it, or over the top of it. And I'm just going to go ahead. You know, I like these numbers here because I kept all those linear numbers assigned, but I'll save those later. I'm going to cut a strip of paper now, so I've got something easy to work with. So we're going to cut that one there. Then you notice we're going to cut the bottom one as well. Now, what you should have left over then is your 2 blank lines that I put on your sheet. I'm not so much concerned that you cut this one out exactly on the line. It's not that important. Okay, so you could go quicker. And there's my one scale. That's my what's called a log scale. We've just made a log scale. Yeah, just cut them. You know, you see where I'm cutting this now here? I'm just going to cut this off. And I'll make, all I'm doing is to try to have some uniformity of everybody's scale, so that if we're uniform, we're gonna multiply numbers now, and that's what we're gonna do. I'm gonna shut the video off for a second so I come around and give you some tape to your individual groups. Okay, so okay, while we were off camera, everybody cut their strips nice and evenly together, except a few people. They didn't, but that was okay. It's not the end of the world. Now, what we're going to do is we're going to actually now multiply numbers. So what I want you to do is within your groups, notice we have a top scale and a bottom scale. What I want you to do first is everybody pick what number they want. Now, let's not pick 1, okay? And let's not pick 10. So here's what I want you to do. Take your scissors and start out cutting the left side. Now remember, I'm on the top one, so your numbers are on the top. I'm going to cut these paper at the number where it was 1. So I cut it on the left edge, right where the number 1 was. So far, so good. On the left edge where the number 1 was. So your top scale, where the number was on the left, you're cutting it vertically right there. So you notice you can't see my number 1 anymore. I cut right through it. So that means if you took your ruler and you measured from the edge of your paper to that marking that says 1.33, you should get the 3 point like some odd centimeters. Now, I don't want you to tell anybody what you're doing next. I want you to do this individually. Now, here's what I'm doing. I know my name. So I'm going to put right on the side that I'm not cutting anything, on the other side, I'm going to put Mr. Huss. And then what I'm going to do is I'm going to secretly write where I'm going to put my cut. Now I'll tell you, here's what's happening. I'm Mr. Huss. I'm going to go and cut my paper at 4.22. Okay, now nobody knows I cut it at 4.22. There it is. That's a segment. That segment is 4.22. That represents the number 4.22. You with me so far? So each of you then write that number secretively where nobody knows what it is. So I'm going to write mine on my other piece of paper that I cut off. 4.22. So I know, I remembered it. That's my number. Okay, and I'm going to turn it upside down just like that. I'm going to leave it blank. I'm going to put it blank right there. That's my number, but you don't know it's 4.22, right? You don't. You have no clue it's 4.22. So far, so good? Now, here's the neat part. Now, I need to have somebody help me with their number. Does anybody have a number? Oh, anybody's number. Travis, bring your number over here. Bring the segment you just cut that you know the answer to. Did you do it already? Well, come on, let's go. Come on. I need yours. Who's done already? Who's done? Okay, Katie, bring yours over here. Okay, now, Katie, bring your bottom scale too. I need Katie's bottom scale. This is where the tape's going to come in. Okay, now, in your table group, I know you guys are talking. You're deciding what your number is. It takes a long time. Katie's going to put her number in upside down right in front of me. Okay, I know it. I know my number is 4.22, right? Okay, put the number that you cut. Where's your cut number? You don't have it? Oh, got to go bring your cut number. Okay, so Katie's, I could look at Katie's cut number, that it is such a itty bitty number, I'm almost going to know for sure what that is. But not really. I'm going to unequivocally tell you what Katie's number is. Now, what if Katie's number was a big number? We might need 2 scales. So Katie's going to take her bottom scale, okay, and she's going to cut her bottom scale at the 1. Well, I'm going to cut it for her because I've got my scissors right here. I'm going to cut Katie. Everybody's going to cut their bottom scale on the left side with the number 1. Okay, now I'm going to take my scale right here, and what I'm going to do, if you got to look closely at what I'm doing, so I'm going to zoom in on it. You want to give me a different number now? Aha, okay, I got you. Katie changed numbers on me. Okay. So I'm going to put and mark my 1 up with the 10 line. You see how I'm lining it up now? I'm lining it up exactly. This is the hard part for you guys to get a feel for this. And I'm making those 2 lines 1 now. Okay, watch what I'm doing again. Remember, I cut the left side off, right? Correct? Cut the left side off. So then I left the right side over. So I'm going to bring that edge right to that hash mark. And so I made a double scale. I'm going to take my tape now. I'm going to take a little bit of tape, and I'm going to tape Katie's scale to my scale. We're going to make one longer scale. Okay, so there. Now let me go zoom back out now. Okay, so I made a bigger scale. This is the scale I made. So I'm going to slide it. I'm going to slide it to the side, and this is 1 here. That's 1. Then this one's 10. So this one's 10 to the first power. Now, as I slide to the right side of Katie's scale, which I brought over here, that becomes 10 to the second power. Because remember, we're adding segments, correct? We're adding 10 times 10 times 10. What's 1 times 10? 10 to the first. What's 1 times 10 times 10? 10 to the second. So watch what I'm going to do with this now. I'm going to take the 2 segments we just put together, and I'm going to start one at the 1 mark on the bottom scale. Does everybody see what I did now? That's Mr. Huss's number. I'm going to put Katie's numbers next to it. I know Katie's number times my number is 13.33 because it's on the 10 to 1 to 100 scale. So this number, can you see by looking at it that my number was 4.22? Does everybody agree? My number, just by matching it on a scale, was 4.22. Katie's number turned out was a number that got me all the way over to 13.33. Oh, you can't see that. So let me slide it over. The camera's not big enough. Do you see now where Katie's number brought it to? It was to the, what we marked was 1.33, but really is 13.3. So I could figure out by taking Katie's number back on the original slide, bottom slide, I know her number was 3.16. So what we did, we added up the 2 numbers, 3.16 and 4.22. But with a log scale, what does that represent? Multiplying the numbers, right? So I'm in my calculator real quick. I'm going to say, wait, does 4.22 times 3.16, does that really give me 13.33? And yes, it does. It really does. Okay, so what I want to do is stop right now for a second. Let's let Katie go back to her desk. And what I want you to do at your desks is take all 5 or 4 of your bottom scales, and I want you to tape them together. And I'm going to come and help and see how you're doing on that. So I'm going to give my bottom scale to Katie's group to make even a bigger one. Okay, off camera.